Here is your first big exercise where we kind of guide you. That's why there's so many numbers here. It's not meant to be a really long exercise, but we're trying to guide you through the process here. So you're going to create a function, some list, where when you're given a list, you have a single return value of how many items, or sorry, all those items that are summed together in the list. I'll spit it out. So anyway, again, I am painstakingly going and having you go through each step on this. So think of this as a guided lab on how you would get this function done. And these are the 10 steps that you would really need every time that we give you a new function to create, which is going to be happening, at least for your lab, but it'll happen in your notes as well. So start working with that, and then we will go over an answer here in a little bit. But please don't just skim right through this. Hit stop, do at least some of the work, and then go from there. So I'll see you in a moment. So let's go through this one by one. Oh, kind of, sort of, because I kind of show you a lot of what's going on here. But number one, what are the parameters and return types that are required? Now remember, in this function, we are just returning a single value, which is the accumulation of all those numbers within a list. So why I bring that up is because we're going to be returning, in many cases, just really an addition that's going to be accumulating all those items. Now addition needs two numbers. So it's going to get the first number from the front of the list, and then it's going to have to wait for the rest of the list. But when we get all the way done, we have to think about, what happens if it's not a list, which honestly I don't worry about in 2A. But if we get to a list that has no items left, what a return, we do a 0. And then if we have a list that has a length of 1, we're just going to return the car in the list. Now remember, by the way, in all three of these are base cases, because notice none of them recall the same function of some list. There's only one recursive call in all of this that has a sum list, and that's our tail recursion at the very end. So that's taken care of, really, number one. What functions do you already know that are required? Well, we know there's going to be car and we know there's going to be cooter, because we're just how we break things up and stuff like that. Null would be a good one. Plus would be another one, because we're adding the items together. And then the length wouldn't be a bad idea. Again, if you didn't get to that one, that's fine. It doesn't bother me. But you're going to eventually need to do it, because in number 3, what are the base case functions that you need to use and why? Well, again, the null, you can cross that out for now. But when it comes to the length, you might have used one or both of these. But we got to think about, what is our final base case going to be? Well, when we go through an entire list, what happens when our list is totally done? What do I do? What can I do that doesn't hurt anything? Well, number one, not call the function over again. Number two, I can simply add, or it looks like subtract here, I can subtract 0 from the entire list. That doesn't hurt anything. I could have also added 2. But anyway, so either one, that would help out with understanding the base case for that. Number 4, what will we need to return from each of the base cases? I kind of went through that already, but still, so you got that one on. Then what will we, let's see, number 5, design your call and value stack. I honestly don't have it here. I bet that I'm going to add this to the notes, so just a heads up on that. But in reality, you should be able to design what the call and value stack is from previous examples, or let's pretend you didn't, which I bet you didn't. I bet that you can draw it from the sum list. So I'm going to add this to the notes after this. There'll be one big picture of this so that you'll see it. But it should be in the stack, call and value stack that we normally know and love. Then we start our coding. So in our coding, I'm trying to give you as many pieces together first, noticing the same order. We use a con. We check all of our base cases first. Our else is that recursive call. And notice the else is only where we have the recursive call. There's 2 parts of the recursive call. So all of these different items, I'm already giving you in a lot of this. So hopefully that you can piece things together when it comes to the overall set with this. And then number 9, code the entire function. Here it is. And then the test cases, I have examples of here that we have below. So with displays and everything else like that. So you are going to need to have these steps every time that we ask you to create a function. Even though this function was only, what, 6, 7 lines long, you're going to need all of these steps to really formulate a very good response to the questions that we give you.